All right, so this is section 4.2 notes. You should have already gone through the book and completed the sections right up top here. Now I'm going to go ahead and walk you through these, and I will leave the classroom exercises described here at the bottom to you to finish, but they're pretty easy. They're basically just a bunch of the problems like these first four that we're going to go over here. So here they're asking us to determine which congruence postulate you can use to prove the angles are congruent. So a strategy you can use with this is to go ahead and start with one of the given congruencies and then kind of walk around it and basically look for connecting properties. So right here, if we start with our single dashes, that's one side that is congruent. Again, you can use your highlighters here to go ahead and show that congruency, make it a little more clear. And then it doesn't have any angles next to it that are congruent, so I'm going to hop to the next side that I see a relationship with, and it looks like both of these two dashed ones are congruent. Okay. And then moving right along to the last one, we see that BC and FE are congruent. So just looking at this and kind of taking stock of what I know, well, it's basically saying that we have two green and then pink and then yellow sides are congruent. And if you completed that first section, you would see that that is side, side, side congruency. Okay, moving along to the next one here. So with this one, if you notice, they don't give us three congruent sides with this one. So I'm going to go ahead and use that same strategy. I'm going to start with one thing that I know. And a strategy that I would use is to use one of them that's on the ends. If you start with the angle, you can see that there's a relationship based off of the two sides surrounding it. So what you're going to want to do is go ahead and start with one of the kind of outer sides here. So we go from a side, and I see that this side is also congruent. And then we have congruent angles, and I'm going to go ahead and make those pink there. Okay. And then I move on, and I have two congruent sides with the two dashes on them. So I'm going to highlight those up as well. Now, if we travel from one side of the relationship, so we'll start at green, we can see that we go from congruent sides to congruent angles to congruent sides again. One more time, that's two congruent sides, the green sides. Then we travel to the right or down, and we get two congruent angles and then two congruent sides. So this one is going to be side, angle, side. Okay. Side, angle, side. All right, now if we move on to the next one, again, I'm going to go ahead and use color to highlight my relationships. And I can see here that one, I'm going to start with my single dash. This side is congruent to the green side here. And then they give me one more, that the two dash side, so CD, is congruent to the two dash side here, AC. Now, I run into a bit of an issue here. Now, all of my postulates, and I can scroll up a little bit here, all have three characteristics to make them true. We have side, 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 angle, and angle, side, angle. Well, looking at these, I have to be a bit cautious here because I only see two relationships. But if you look, you should notice that both of the triangles share one of the sides. So I could even highlight up that side. Now, if I look at the three sides of each triangle, well, here I have a green side that's shared, that's one. Then I move over and I have a pink side that's shared. And then I rotate to the middle, and they both share BC. Well, that means that BC is congruent to BC. Okay, that is the reflexive property. So based off that, we have that AB is congruent to BD, AC is congruent to CD, and BC is congruent to BC. So this would be a side, side, side relationship. Now moving on to the last one, we'll do the same thing we've been doing. I'm going to highlight, I'll start with yellow this time. Okay, my sides with one hash mark, I know that those are congruent. I'm also going to go ahead and highlight the 2' side, since I know those are congruent. Again, geometry is all about relationships, so we want to make it very clear which relationships imply congruency. Now the last thing is that I know that this angle here has one dash, and so does this one, so these are congruent. Now this is where it's going to become important that we go in order. So for this one, we can see we have the two yellow sides, so we start with a side that is congruent. Okay? Then right next to it, I have another side that's congruent. And then I travel a little bit more around the triangle, and right next to that side, we have these two green angles that are congruent. So I have side, side, angle. Okay? Side, side, angle. And again, we start with the side, then we have to go to a side that's right next to it, and then the angle that's right next to it. Now, this is a very common mistake. If we look back to our postulates, you'll notice that we have side, 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 which obviously doesn't match up with this. We have side, angle, side. Again, side, side, angle is not the same as side, angle, side. And we have angle, side, angle. Well, that is also different than this. This one has the sides next to each other. The only one of these three that has two congruent sides next to each other, okay, is side, side, side. We don't know that that's true because there's nothing stating that these two angles or these two sides are congruent. Therefore, in this particular case, we cannot prove congruency. That one's a little tricky. Take stock of that. Side, side, angle does not prove congruency. Now, moving on to the proof here. Ooh, it's a proof. Hey, but they did most of it for you. And we're going to simply mark up our diagram as we are used to. Now, a few pieces of information that they give us. One, they tell us that BA is perpendicular to Y, Z. Therefore, I know that it creates a right angle. In fact, two right angles there. It also tells me that BA bisects YBZ. Okay? And so I can go ahead and say, well, I know that this angle must be congruent to that angle there. Okay? Now, they want us to prove that triangle AYB is congruent to AZB. All right, so going through the problems here, first, there's a statement that is not given, and it states if two lines are perpendicular, that perpendicular is going to be pretty important, they form congruent adjacent angles. Well, if I look up here, I did have a statement that talked about perpendicular, and it told me that these two would be right angles. Okay, and they're adjacent, so I can be pretty confident that this statement, if they're talking about congruent adjacent angles that are formed by the perpendicular, well, they're talking about how angle 1 must be congruent to angle 2. Now here, and since they're congruent, let's go ahead and highlight them up their own color. Okay. All right. Now, the next is is given. Well, the other piece of information that was given here, and actually this is a bit of a mistake in that I'm pretty confident that they should have made this statement first, but we'll give it to them on this one, is that the next given would be that BA bisects YBZ. Or you could state that BA is a bisector of YBZ. So here, the next statement, they say that angle 3 is congruent to angle 4. Well, we already marked that up, and we knew that because any bisector will form two congruent angles. So this is the most basic concept. Generally, those are definitions. Definition of an angular bisector. Okay. Now moving on to the next statement, AB is congruent to AB. Well, that might seem very obvious. I'm going to go ahead and highlight it because I know now that that's another piece of information that I'm going to use. Well, that states, okay, AB is congruent to AB. Well, that is due to, I mentioned that we were going to use it again up here, the reflexive property. Think of a mirror. When you look in a mirror, you are equal to the image in the mirror. Okay? So this one would be the reflexive property. Lastly, okay, it's the last statement, so I'm pretty sure we know what we're going to do, but they say angle side angle. So let's take a look. We start with our yellow angle here. So we have angle, then they share this pink side, so those are congruent. Angle, angle, side, angle. Angle, side, angle. Okay, and they're all right next to each other. That's important. So this is our final statement, that triangle AYB is congruent to triangle AZB. Okay. Okay. And again, we can double check that those are corresponding. A's should correspond. Well, they both share A, so those are definitely both corresponding. Then we look at Y and Z. Those are definitely corresponding angles as well. And then B, of course, would correspond with B. Go ahead and attempt problems 1 through 9. You'll find that they're not too bad. Just look back to your postulates and then the rules right up here if you run into a roadblock. And of course, as usual, come in with any questions you might have.